Okay. And I'll get the screen share going too. Okay, so today is all about test one. Test one is due on next Friday, September 25th at 11:59 p.m. You should have received a message from me in Canvas saying what the password is to access the test, just so you don't enter it until you really are ready to take it. So some particulars about the test. All right, first, 2 hours has been allotted for it, and there are 20 problems from all the lessons that have been covered in Chapter 2, and the 2 lessons from that we've done in Chapter 3. Okay. And what I'm going to do today is I'm going to go through the types of problems that show up on the test, and give you a process for working those problems. Now, what you should do as part of your preparation, so what I cover today, the practice test. So that is up too, and I haven't seen much activity on it, or very little last time I checked. So a practice test is literally a copy of a real test with just certain particulars changed. So try it out so that you know what you're in for. I would also encourage you to try it, even though the practice test does not have a time limit imposed, but I would suggest imposing a time limit on yourself, just to make sure that you're able to do the real test in the allotted time. Other things, wait, let me see what's going on in the chat. Okay. Is anyone able to hear me? Please let me know.
Yes.
Okay. Thank you. So I'm not sure. Yeah, Ray, I'm not sure what's going on then. As to why you can't hear me. If a problem is not resolved during class, at least you'll have the video that'll have all the audio. So I'm sorry, I don't know what to tell you, but it appears to be something happening on your end. All right. Now, very important for you to be aware of. Okay. So once you take a test, of course, once you submit it, then you'll see what your score is. If you're not happy with it, it's not the end of the world. Don't freak out, because there are 2 things that can happen that would both have the effect of raising your score. So one thing I will do is I will review every question for partial credit, every question of every test. That means don't leave anything blank. If you don't attempt, oh, okay, I'm glad you can hear now, Ray. If you don't attempt a question, if you don't put an answer down, obviously nothing I can do for you as far as partial credit is concerned. So, like for example, suppose you're given a function with several terms, and the problem requires you taking a derivative, and you get some of the terms right, but not others, then that's worth partial credit. Each problem is worth 2 points. So that gives you a way to give you like half credit or possibly full credit, which I will do in some cases if you're like incredibly close, like you just missed it by a hair. All right, so partial credit can make a substantial difference. I've seen scores go up by 20 points or so. So that's one thing. Also, after I've graded everyone's, it is possible that I may shift the scores up. Historically, I have done that. How much I do that, it just depends on how things go. So I shouldn't make any further comment about it. But so since the test is due on a Friday, then by the following Monday, that'll be enough time for me to have gone through everything, reviewed for partial credit and so on. So then you'll have a good idea of where you stand. Also, keep in mind this test is 25% of your overall grade. So all the lessons put together, that's 25%, and then you have test 1, test 2, final are 25% each. But if you do better on the final exam, like if the test 1 is your right, so if test 1 ends up being your lowest grade of the 3 tests, then the final will replace it. Therefore, the final on which you would have done better would count for more of your grade than it would otherwise. So if it helps your score, it will replace it. So my point is, there's really, at this point of the semester, there's very little of your grade, even after taking this test, there's very little of your grade that is actually set in stone. So if you're not happy with where you are at that point, there's still plenty of opportunity to improve that. Okay. Okay. So what I'll do, I'll go through the various types of problems, and then, you can imagine after going through the lessons that a lot of the problems will be, here's a function, take the derivative, and you'd be right. But there are other things too. So, and once I go through all of those, we should have some time left over for questions. All right. Okay. First type of problem. Average rate of change. Now, this is a problem we haven't seen in a while, because then we got to the derivative and we've been doing that ever since. Back in your memory for this one. The formula for average rate of change. Average rate of change of a given function f of x on an interval, or from x1 to x2. So you have to be given a function and 2 x values. So that average rate of change is f of x2 minus f of x1 over x2 minus x1. So difference in y values divided by difference in the corresponding x values. So you may be given a formula for f of x, so you're doing plug and chug to get these values, or there are at least a few problems where you're given a graph of a function and certain points are marked. So you're given these f values, and then you work out this out from there. Now, I cannot emphasize enough. I see so many mistakes on these kinds of problems that are entirely preventable. You literally have the x and y values on a graph. You're given the numbers to subtract and then divide. And time and again, I experience a heartbreak of seeing so many points just given away from not doing this right. I was looking through a practice test, or actually a few of these problems. There are 20 problems altogether. A few of these are V's. So these probably are among the easiest points that you can get, because there's so many problems where you're having to grind through getting a derivative of some nasty function. And this is something that would take a lot less work. So don't rush through these so much that you end up shooting yourself in the foot. So all the more reason to go for a practice test. And while this applies to all problems, of course, and this one, I shouldn't be seeing any mistakes on these. So yes, after the test, if I do, I will be giving you guys crap about it. Okay, now, next type of problem. This one is kind of the duh, but here's a function, find a derivative. But it's worth taking the time to talk about the various differentiation rules that you should all have fresh in your mind. Now, we have, for example, the coefficient rule. So if you have the function that's just a constant times x, then it's just that constant. So you see a 4x, the derivative is 4. Actually, I'll put this even before this one because it's more basic. Constant rule. Derivative of just a constant by itself, 0. I see it happen now and then where a function has a constant term in it, and then that just some people will just carry that over into a derivative. Yeah, don't give away points like that. The sum rule. So if you have two functions that are added or subtracted, so it works either way. If you just replace g by minus g, then you are allowed to take the derivatives of f and g individually and add the results. So sums and differences. You can do that. And just for completeness, I'll throw that in here. Okay. Now we get to the nastier ones. Product rule. You have two functions multiplied together. So you have two terms. You're taking the derivative of one of the factors in each term, leaving the other one alone. I use P and Q to refer to your ducks for a problem like this. So identify your two pieces, take the derivatives of them individually, then you have your ducks in a row, and then you just put them together according to this rule. Similarly, the quotient rule. All right, so if you have P divided by Q, the numerator has a very similar appearance to the way I've written the product rule, but we have a minus in between. Therefore, order is important. Bottom times the derivative of top minus top times derivative of bottom. I actually formatted these rules in the same way to make it easier to remember both of them. Okay, and then you have a denominator squared. All right. So again, get your ducks in a row, put them together according to this. Okay. And then finally, we do have a chain rule that I went over, but the only case in which you, what really important rule have I skipped over? Who can tell me?
The power.
Yes, I got so caught up in how to handle various combinations of functions that I just went right by that one. It's important enough that it should be one of the first. So you just have plain old x to a power. Then you have this rule. So thank you for that. It's probably a rule that you use more often than any other. Okay. Now, all right. So the last rule that we have, the general power rule for a similar situation, where now you have a function f of x raised to the nth power and instead of just a plain old x. So that would be exponent still comes down. You're still raising what's being exponentiated to a power what's one less, but because it's f of x rather than just x, you must multiply by its derivative. All right, so here, do not put a derivative here. The original is raised to the n minus 1 power. Derivative goes out here. Don't forget it. Okay. All right, so there are many problems on this test that require just taking derivative of some function. These are the rules that you should know. And we'll actually see more rules before we're done, but these are the ones for this test. Okay, before I get to other types of problems, are there any questions so far?
Are you gonna go the power rules and the ones where you do like the product and like the chain rule and kind of do them like combined, those kind of problems?
Okay, I'm sorry, I missed the first part of your question. The audio is terrible.
Are you gonna do problems like where you're doing like the, the the different rules together, like kind of like when you do the product rule and the chain rule in one problem?
Okay, I want to emphasize that here, my purpose today is to go through the various types of problems and give you the information you need to do them. Now, so my plan today is not to actually work through specific problems. That's what the practice test is for. Now, I will make an exception in this one case, but again, I'm here to show essential concepts that you need to go through, and then you apply those on the practice test. Okay. Okay, so if I make up a function that involves that, okay. Actually, what I'm doing is I want to make this more relevant to the test. So I'm actually looking through the practice test right now. I'm actually not seeing any such problems in the practice test. And all the rules that I've just gone through, you do need. But so that's one thing to keep in mind, that on the practice test, there does not appear to be any problems that require to use these rules in combination. If you did, it would go something like this. Whoops, x to the 4 over 5x to the 2. So what I did here is I took a function that's from a practice test, and I just put a square root on it. Now, if I were to take the derivative of this, what should I do to it first before I actually take a derivative?
You have to put it in 1/2 power.
Yeah, so it's not currently written in a form that's conducive to taking the derivative. So this is worth bringing up, certainly for that reason. Whoops. Dang thing. So it's that whole thing under a radical sign, but raised to the 1/2 power. So if you have a function on a test that's given to you as some kind of radical, and you need a derivative, first thing you do, write it in this form using a fractional exponent. Okay, then, so this, taking a derivative of this requires several, but two rules in particular. What is the rule that I should use first?
General power rule?
Yes, general power rule, because in evaluating this function, you work out the fraction first. What's the last thing you do? Take a square root. So that is the first thing you deal with in taking a derivative. So last operation is differentiated first. So general power gives us 1/2. Then that same fraction untouched, but raised to the minus 1/2 power. And then what remains? What do I need to use now? To finish this off. Which rule? Yeah, we have a question here. All right, so then go ahead and do that. So denominator times derivative of the numerator minus numerator times derivative of denominator over the denominator squared. Okay. I won't bother simplifying this. I want to leave it in this form so you can see where the individual pieces came from. But are there any questions about how this derivative unfolded? All right. But it looks like no problem like that made it onto the test. And I'm sure you're fine with that, and honestly, I am too. Okay. Okay. Now here I was just talking about problems where the only thing asked for is the derivative, but there are quite a few problems where the derivative is needed as part of finding something else. So you can expect a problem like this. Find the slope of some given function f of x at some given point. So that's a given information. Okay. All right. So you're given a specific function and a specific point. You'd be given actual numbers here. Well, the slope is just going to be it's just going to be the derivative. So f prime at whatever x value you're given. So really so different from the other problems. You're taking the derivative, but at the end, one last step, you just got to plug in this given x value. So that's really all there is to that. And this gets into the interpretations of a derivative. Is the slope of a tangent line. So it's dang thing. You're taking the derivative at a certain point. But the slope of a tangent line at that point is given by the derivative. So whenever a problem mentions slope of a tangent line or slope of a function, that's what they're referring to.
I have a quick.
Yep.
So if it's a slope of the function, would be average rate of change?
Not if it's at one point.
Okay.
Average rate of change would be slope over an interval.
Oh, okay. So I was thinking like slope of an entire function would be average rate of change, and then like.
Oh, I see. Yeah.
Yeah.
Yeah, because slope of a function is kind of essentially synonymous with slope, or really ways to find slope of a function. Slope, we associate slope of a line, really.
Yes, sir.
So it's synonymous with slope of tangent line.
Okay, I was just confused. Thank you.
Yep. Okay. Now, next type of problem. Okay, so there's let's see some questions that are multiple choice. Well, and you're also computing something. So you're given a function, excuse me, and given some x value, so x equals a. So the question comes in two parts. The first part is you find a function value at a certain point, and you have a multiple choice question for interpreting it. And then the second part is find a derivative of a function at that same point. So you're working out these two things, and a multiple choice question for interpreting that. Again, I see all kinds of mistakes on these, and you're going to see these on the practice test. You can see what the right answer is going to be. So then get those points when it comes to the real thing. So one, and actually this gets to what I was just talking about in response to the last question. So this, the timing is good there. That the derivative is the instantaneous rate of change. Not the average rate of change. And as I mentioned earlier, instantaneous rate of change, and therefore derivative, is what's happening with a function at a single point, which is what this kind of question is about, as opposed to average rate of change that happens on an interval from one point to another. So it involves two x values. I see so many students, when asked to interpret f prime of a, they'll check the choice for average rate of change. It's one of the distractors. So it's not the average rate of change. So please don't let me see anyone choosing that answer, because I have enough gray hairs as it is. Okay. Another term that comes up actually, we haven't even talked about this. Total change in a function. That means something else entirely. And it is something that I'll be able to talk about as we get to the end of the semester. So you're going to pick a multiple choice question, you can at least pick some terms we've actually talked about. Okay, so again, these are among the easiest points you can get on this test. Don't give them away. All right. Now, for something like this, if you get this part right and then you get the multiple choice wrong, and vice versa, Hawks won't give partial credit, but I will. But it's not the sort of thing that you really should be angling for full credit on. Okay. And there are similar questions, not multiple choice, where you have to evaluate the function and its derivative as specific x value. So it's in within the context of a word problem. So you're given some function f of x, and you're told what it means. Like, for instance, it might refer to like some of the examples we've seen: population growth over time, something like that. And you're looking for an okay. Like one of the problems in a practice test, the function that's given refers to it's interpreted as total fertility rate in a country. So that's the first part of the question. What's the total fertility rate? So you just evaluate the function. So the problem doesn't ask what is f of x. It's based on the meaning of a function that's given in the problem. So it's really testing your reading comprehension as much as anything else, or whether you're paying attention to what the problem is saying. So for such problems, so based on meaning of each. So the first, so for example, like if f of x refers to total fertility rate, and it's going to ask you what is the fertility rate at a certain point in time, you're evaluating a function. The second part will be what is the rate of change of whatever quantity it is, such as total fertility rate. That's code for derivative. So at a rate of change, means take the derivative. So this is about understanding what the derivative means as a rate of change. Right. Okay. The last couple types of problems deal with certain business concepts. So marginal cost. So if you're given your cost function, c of x, remember marginal is also code for derivative. So marginal cost is its derivative, c prime of x. The problem's not going to tell you what is a derivative. It's asking for marginal cost, and so you have to know, but that's derivative. Similarly, we have marginal profit from a given cost function, again c of x, and demand function d of x. So given this, figure out marginal profit. So what are we using here? Marginal profit is p prime of x, but that is equal to the marginal revenue minus the marginal cost. So you need a derivative of this given function c, where the revenue function is x times d of x. So d of x indicates the price at which the item is sold. X is the number of items, so R of x is the total revenue you will get from X items. Okay, so don't miss this step. Make sure you multiply the given demand function by X first. There's your revenue. Then you put together your profit function and take the derivative. So yeah, P of X is profit function is revenue minus cost. And that's where this comes from for marginal profit. So if you are able to do these 7 types of problems that all of which you would have seen from various lessons, then you're good to go. If there are any lessons that you have not gotten certified on yet, I would encourage you to go back and do that. Even if you're late, if you're only a little late, like you're less than 5 days late, you can still get full credit. Otherwise, there would be a 25% penalty, but certainly better than 0. And the lowest lesson gets dropped. So that's another form of practice with some learning aids and so forth before you go to the real test, or even a practice test as a precursor to the real test. Okay. Now, does anyone have any questions about the test?
I don't have a question, but thank you so much for reviewing.
Oh, you're welcome. That reminds me. Since this will all be going on next week. Okay. All right. So. All right. So I will not be covering new material yet because y'all are going to have a test going on. I actually want to check my schedule here. Okay, right. So until the Monday following a test. Okay, and I actually had in mind to simply cancel class altogether. So I guess what you could say is, as far as you're concerned, if you want it to be, then class is canceled. But since I'm accustomed to doing this anyway, if anyone has any questions about anything, whether it's related to the test or whatever lessons you might have going on, so I'm still gonna. I mean, I'm gonna be here anyway in my office. So what I'll do is on those days I will tune into Teams. Now, I mean, I've been holding my office hours on Tuesday and Friday at 9:30, and we hit a milestone that it was this week when I finally got a mathematical question during one of those office hours. So it was a miracle. So, but otherwise, I've generally had like a free hour in my schedule when these happen. But that's fine. It's very free to use if you need it. But otherwise, you're free to simply not show up. Okay, so we'll pick up with the next lesson, which is 3.4, after the test is in the books. Okay. And these notes will be posted as usual. Actually, out of morbid curiosity, because I'm able to check, and Hawks tells me a lot of things about what y'all are up to when using it. Like, you know, how much time are you spending in a lesson, learn, practice, certify? Did you take a practice test? How well did you do? How much time did you spend on it? So if I look at the this practice test, two people have looked at it, and they spent 1 minute each. So, but the test is still a little over a week away to due date. But I'll simply say, really, I have two comments here. One, as we get to next week, I better see a whole lot more activity than that. And number two, I see a lot of instances. Well, since Hawks tells me how much time you spend on a test, I see a lot of instances where someone gets a low grade, and I also see very little time spent. And it's something that I've observed in general, like even when teaching face-to-face classes and giving tests there, with the background that this USM is the fourth university that I've taught at, and students have a lot in common no matter where you go, but there are two things about observations I've made during my 11 years here about USM students that distinguish them from students I've seen elsewhere. Number one, you guys are awful about seeking help. Now, obviously, there are exceptions, but even when help is definitely needed, even when help is being enthusiastically offered, it's not taken up on, when that could lead to doing a whole lot better later, by clearing up misconceptions and so forth. When I was a student myself, I was in my professor's office hours very often, and it did me a lot of good. And what I don't know. Well, I can speculate as to what the hangup may be, and I could also understand that some of my colleagues in the faculty throughout the university might swing the other way in terms of being discouraging towards seeking help. But it's something that I want you to think about. That if you're doing great, okay, obviously there's no need. But if otherwise, it's something to think about. The other distinguishing aspect, again, this is just as a group, obviously there are exceptions. You all give up on tests way too quickly. It was kind of shocking to see students show up for an hour test and they're out of there after 20 minutes, and not because they whizzed through problems, it's because they just gave up. And it's especially disheartening if they end up leaving things blank when maybe they could have got some partial credit. I know I've had it happen when I was a student where I see something and initially I don't know what to do, so I move on. I try to work out everything else, and then I come back to it. And sometimes things would come back to me. I just had to give it time and settle down. I mean, it's easy. Obviously, you're very stressed. You have that brain freeze, and that's actually why I give as much time. These tests used to be an hour and a half, and I bumped it up to 2 hours. So that if you have that anxiety at the beginning, that I want to give you time to get past that, because your brain needs to be at your best, and all those all that stress just gets in the way of letting your brain do its job. So these are things I want you to think about. Okay. All right. So that's my preaching for today. If anyone has, since there's still plenty of time left in the class period, if anyone has questions, they can stick around to ask. If not, I'm going to end the recording here. And if you don't have any questions, then